Hello, hello, wherever you are. Right, this question is about, let me draw it. We've got a 3 meter long bit of metal, like that. So it's 3 meters long, bit of metal. And it's been warmed up from 27 to 150. So we're adding a bit of heat. So we go from 27 degrees up to 150 degrees C. Which is going to make it expand because we're doing thermal expansion. All right, so thermal expansion. So this metal bar is going to expand a bit. Okay, for now, we're just going to be going that way. So obviously, you know, when you heat things up, they go expand a bit, don't they? But we're just going to go in one direction. So it's going to be warmed up. It's 3 meters long. It's going to expand a bit. The coefficient of thermal expansion, that is a material property. That's the symbol for it. That is 24 times 10 to the minus 6. Okay, that's just a property of whatever this material is. And we've got to calculate the length after heating. So we've got 3 meters. It's going to be warmed up a bit. And it's going to change in length because things expand in heat. Okay. So we've got to find that change in length. It's quite an easy one. Okay. So we know that change in length due to heat, here's the formula, is length, which is original length, times by thermal expansion, times by change in temperature. That's the formula we want. See if I can move down a bit here. Well, that's the formula we want. Tink, 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 tink. So different color pen, different color this. So we know now the change in length is going to be the original length, which is 3 meters. If you put it in 3 meters, it comes out in meters. Put it in millimeter, it'll come out in millimeters, but we'll use 3 because the unit of length is a meter. Times by the coefficient of thermal expansion, which is that 24 times 10 to the minus 6. Times by the change in temperature, which was 27 to 150. Okay, so we're getting hotter. So I'm going to go 150, take away 27. This will give us the change in length in meters. So whack that into your calculator, and you might get something like this, 8.856 times 10 to the minus 3 meters. Okay, because we're in meters, that 3 was in meters, so this goes out in meters. That is the same as saying 8.856 millimeters, because 10 to the minus 3 is millimeters. So the change in length is that much. That's how much this metal bar is expanding due to that heat, almost 9 millimeters. Quite a lot if you think about it. It's asking us to find the length of the bar after heating. Right? So after heating, so all we've got to do, it starts off at what? 3. And we've got to add then the change. The change in meters was this 8.856 times 10 to the minus 3. Whack that in your calculator, and the new length after heating is going to be 3.00886 meters. That's the new length. That's the answer. is expanded about 9 mil, so hopefully there's room for it to expand. Okay, so that's the question done. Thank you very much. The answer is 3.008856 of a meter. It's expanded by just under 9 millimeters. Okay, so that's that question done.